Good afternoon, class. Today the topic will be the Pythagorean Theorem. You've seen this before many times. However, I just have to go over it again to make sure that you understand it. We've used this already a few times this year. The Pythagorean Theorem is when we deal with right triangles. So we have to remember all the parts of a right triangle. The right triangle has three sides, three angles, just like any triangle. However, the two sides that make up the right angle of the right triangle will be called the legs. The side that is across from the right angle is called the hypotenuse, and the other two angles in the triangle are acute angles, which also happen to be complementary angles, which, if you remember what that word means the other two angles of a right triangle have to add up to be 90 degrees. If you want to remember it, the acute angles of a right triangle are acute, so give them a complement. Just like this diagram here, that's what you need to match up. This was already back in chapter 4. You should know this at this point. It should be straightforward. 1, 2, 3, done. Now, Pythagorean's theorem, I know I've mentioned it and I know we've done stuff with it, we just actually haven't calculated with it. Pythagorean's theorem is how we find the third side length to find over the other two. So when I want to use this is if I'm looking for the third side length of a right triangle and I already have the other two. And the only way I can use this theorem is if I'm dealing with the right triangle and I know the other two legs. So the conditions, it's a right triangle and I know two of the three sides. When do I want to use it? When I'm looking for the third side length. What is Pythagorean's theorem? It's the leg squared plus the leg squared equals c squared. So if I would have a triangle like this, c will always be the hypotenuse. It's always across from the right angle. In this case, it would be c squared equals a squared plus b squared. The hypotenuse squared equals a leg squared plus a leg squared. That's all it is. If I gave you numbers here, like for instance, a here is 7, c is 25, you just plug the numbers into their appropriate spot. C being 25, I put it over here, c squared equals 7 squared plus b squared. Solve for your unknown, b. That's all Pythagorean's theorem requires us to do. It's pretty nice, simple, straightforward theorem. Alright, let's look at a few examples. Example 1, I want you to find the length of the hypotenuse if I know two of the three side lengths. So, redraw your triangle, put the lengths in, 16 and 30, and I'm looking for the last one here, the hypotenuse, x. Well, I'm looking for a third, I have 2, and it's a right triangle. Those are all clues that I'm using Pythagorean's theorem. A squared plus b squared equals c squared. It doesn't matter if I say c squared equals a squared plus b squared or vice versa. It's the same theorem. 16 is a because I just randomly chose it to be. B is 30. And c is what I'm looking for. So, solve for x. 16 squared is 256. 30 squared is 900. X squared is x squared. Add these two together, you get 1,156. And at this point, if I have my answer, I'm looking for x. To get rid of the square, I have to do the square root. So the square root of both sides, I get x to be 34. Awesome. This is Pythagorean's theorem. This is example 1. You should be able to do this. Plug in the numbers into the right spot. For example 2, I made a slight mistake. I copied the same triangle twice, and I never changed the numbers for the right triangle. So, copy these down quickly, and then try the left one, but leave the lengths for the right one out for now because we're still waiting for it. Alright, these are the two triangles that I decided to come up with. On the left side here, I'm looking for x. Let's change the right triangle here just a little bit more. Let's make this x and make this over here too. Alright, so I look. Right triangle, looking for the third side length. So automatically a squared plus b squared equals c squared. A I'm going to call, I guess I really should call it x. So x squared plus b squared, 12 squared, equals c squared or 15 squared. Now look, I'm trying to solve for x. So x squared plus 144 equals 225. Subtract 144 from both sides, x squared equals 81. Take the square root of both sides, x equals 9. Awesome. Next triangle over here, I'm looking for a side. I have the other two. Pythagorean Theorem. A squared is 2 squared. B squared is x squared. C squared is 4 squared. 4 plus x squared equals 16. X squared equals 12. X is the square root of 12. What do I do? Well, if I'm looking for simplest radical form, I have to keep the square root. If I'm looking for a decimal, punch in a calculator. Give me to where I asked it to be rounded to. In this case, simplest radical form. So I'm trying to pull out a perfect square. 12 is 4 times 3. And 4 is a perfect square. X equals square root of 4 times the square root of 3. And the square root of 4 is 2, so my answer here would be 2 square root of 3. And there we go. Another two applications of the Pythagorean Theorem. When I'm looking for the third length, plug it in, solve. Awesome. Example 3. Yeah, unfortunately, I don't always give you a picture. Sometimes I give you a word problem. And here you go. There's a word problem. The top of a ladder rests against the wall, 23 feet above the ground. The base of the ladder is 6 feet from the wall. What is the length of the ladder? They give me enough information here to solve this problem. So what I have to do is, first of all, draw myself a picture. If I don't draw a picture, it's going to be tough on me. Because I'm a visual guy. I need to see what's going on. Well, if it's a wall, it's straight up and down. If it's along the ground, it's straight along the ground. I imagine that's a right angle there. If it's 23 feet tall, I write 23 feet. If it's 6 feet from the ground, I write 6 feet from the ground. It's a ladder. It's leaning against the two. I connect it. I got a right triangle. And I'm looking for this. I could have asked, what's the length of the hypotenuse of this right triangle? Yeah. But instead, we're applying it to real life. We have to be able to draw the triangle, set it up, and solve. Now that I see this, it's just a squared plus b squared equals c squared. 23 squared plus 6 squared equals x squared. Ooh, 23 squared, I'm not sure off the top of my head, so this is where I pull up my calculator. Add the two together, I get 565, and I'm pretty sure I can't reduce this in radical form. So at this point, I would type it in the calculator. Square root of 565, and I get 23.77. And there we go. The ladder is, I guess I should say, 23.77 feet tall. Or 23.77 feet long. Alright, let's look at another example. This one is a little bit tougher. Because in all of these here, all I was trying to do is find the last length of a triangle. But this one says, find the area of the isosceles triangle. So I'm not looking for just the length here, I'm looking for area. Ooh, it's a triangle, right? Well, first things first. If it's isosceles, I'm drawing an isosceles triangle. If I'm finding the area, I'm going to write down the area equation. Area equals 1/2 base times height. Alright. I'm told the three side lengths, 10 meters, 13 meters, and 13 meters. Well, here's my base. I need the height. Base and height are always at a right angle to each other. Oh, the height of this triangle will be from here to here. The altitude. That'll be h. Oh, wait a second. In chapter 5, we talked about what an altitude of a triangle is. First of all, it's this right angle from vertex to the other side. But if it's an altitude of an isosceles triangle, and it's going from the vertex of the isosceles triangle, it will also be the median, the perpendicular bisector, the angle bisector. So there's about 4 or 5 things I could fill in here. First of all, angle bisector. It's a median, so it cuts it in half over there. Wait a second, it cuts it in half? I know the full length is 10, so half the length has to be 5. And if I look very closely, I have a right triangle here. 5, h, and 13. Well, I have the base. I need the height, so I can plug into my area formula. Solve for h. 5 squared plus h squared equals 13 squared. A squared plus b squared equals c squared. 25 plus h squared is equal to 169. Subtract 25 from both sides, I get 144. Take the square root of both sides, I get h to be 12, but that's not my answer. I have h to be 12, I have b to be 10, so area is equal to 1/2 10 times 12, or area is equal to 5 times 12, or area is 60 meters squared. It's really not that bad, but you have to know how to draw the picture and solve. Otherwise, it's just find the unknown length using Pythagorean theorem. Once I found the unknown length, I plugged it into my area formula, and I'm good to go. What people eventually found is that because triangles that have the same side are congruent, always, side-side-side congruence postulate, side-side-side congruence theorem. If I know this is 5, this is 13, and that's a right angle, I automatically know that h will always be 12. In fact, there's certain numbers that we memorize to identify if it's a right triangle, like that. And these are called Pythagorean triples. They're just 3 whole numbers that satisfy Pythagorean's theorem. So when I plug it into Pythagorean's theorem, I get 3 whole numbers. It's a Pythagorean triple. A squared plus b squared equals c squared. If I plug 5, 12, and 13 in, it works. So if I see 5 and 13 on a right triangle, and the 13 is the hypotenuse, I know the other leg's 12. 5, 12, 13. There's also 3, 4, 5, 7, 24, 25, 8, 15, and 17. And these are just shortcuts to be able to say it's a right triangle. So if I give you a triangle like this over here, 5 and 4. What's the last length? Well, I could use Pythagorean's theorem to find it. However, the hypotenuse is 5, one of the sides is 4, that looks strangely familiar to a 3, 4, 5 right triangle. So this side has to be 3, because that's what would make it a right triangle, 3, 4, 5. What if I had a triangle like this? 10, 8, and I'm looking for the last side. Oh, 10 is 5 times 2. 8 is 4 times 2. So this side is probably going to be 3 times 2. 3, 4, 5, just a multiple. 6, 8, 10. That's what these Pythagorean triples will allow you to do, is shortcuts like none other. You can look at it and say, I already know the last side. When I was doing this problem, I knew h had to be 12. Before I got down here, I already knew what h was. I knew it before here, because I have it ingrained in my head what these different types of triangles are. 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, and 17. There's actually an infinite number of these. I'm only asking you to memorize 4. I think 4 out of an infinite number is pretty fair for you. So you got to memorize these 4. I might ask which one of these is not a Pythagorean triple, and you should just know by sight. So again, I want you to memorize the ones in purple at the top. Those are the ones that you need to know. Well, using Pythagorean triples, solve these 3 triangles. Alright, the spot I always like to start with whenever I'm doing a Pythagorean triple, or I think it might be a Pythagorean triple, is I usually like to start with the largest side or the smallest. And seeing the only way I can use Pythagorean triples is if I'm given 2 side lengths, I'm going to have either the biggest or the smallest, guaranteed. If it's the hypotenuse, that's the one I'd like to compare it to. 15, I don't see 15. However, 15 is a multiple of 5. In fact, that's 5 times 3. The only triple it could be right now is this one. The others are eliminated because the hypotenuse doesn't work. Alright, 4 and 3. Well, if I did 5 times 3, this is either 4 times 3 or 3 times 3. And in fact, this ended up being 4 times 3. Which means if I want a 3, 4, 5 right triangle, I need to have 3 down here. 3 times 3, so x is 9. Wow, then I have to use a single square, and I already have x. Go ahead, plug it into Pythagorean's theorem. X squared plus 12 squared equals 15 squared. x squared plus 144 equals 225. X squared equals 81. Square up both sides, x equals 9. Wow. You mean I did that without having to do this because I knew the triple. Time saver. Alright, let's look at the problem in the upper right. 8 and 15, I'm not given the hypotenuse. So I'm not going to look at the right side. I'm going to look at the left side. Do I see 3, 5, or 3, 5, 7, or 8? Well, this could be a multiple of 5. However, this is the shortest side. That's the one I want to look at. So 8. 8, 3, 5, 7. 8's right there. Let's just try that one. 8, 15, x is 17. 8, 15, 17. Done. How about this one over here? Well, I'm not sure if 14 is the shortest side or the longest. Well, shortest or medium. However, I know 50 is definitely the longest. I look. 50. It's either 3, 4, 5 or 7, 24, 25. It's either 5 times 10 or it's 25 times 2. Well, let's just try 5 times 10 first. Is this 3 times 10 or 4 times 10? No. 3 times 10 is 30. 4 times 10 is 40. So that one's out. It was good consideration, but it's gone. Well, let's try 25 times 2. Well, 25 times 2 is this one. So is this 14 either 7 times 2 or 24 times 2? Well, yeah, it ends up being 7 times 2. So if I want 7 blank 25, 7 blank 25, it's got to be a 7, 24, 25 triangle. But if I multiply this one by 2 and this one by 2, this one also has to be multiplied by 2. X is 48. I did that without using Pythagorean Theorem. Knowing these 4 right here is going to help you a whole lot because these are always guaranteed to be a right triangle. Know these 4, know their multiples. So like 6, 8, 10, 10, 24, 26. Know those, and you will make your life a whole lot easier in this section. I believe that's all I have for you today. Till next time.